Good morning, one and all. My name is Dr. SARON. I'm a senior lecturer at the Department of Conservative Dentistry and Endodontics at Mahi Institution of Dental Sciences, Puducherry. Today's topic that we'll look into is the electronic apex locators. Moving on. We'll be going into introduction, history of electronic apex locators, classification and working mechanism of each generation, general accuracy of frequency-dependent electronic apex locators, common problem solving, and what are the other uses of electronic apex locators, and conclusion. So, introduction. Locating the appropriate apical position always has been a challenge in clinical endodontics. CDJ, ideal physiological apical limit of the working length, referred to as minor diameter or apical construction. CDJ and apical construction do not always coincide. So the apical construction does not coincide with the anatomic apex, deviated linguobuccally or mesiodistally from the root. Electronic apex locator operates on the basis of electrical impedance rather than visual inspection. The electronic apex locator is particularly useful when the apical portion of the canal system is obscured by certain anatomic structures, such as in cases of impacted teeth, tori, zygomatic arch, excessive bone density, overlapping roots, shallow palatal vault. To determine the working, that's an important adjunct to radiography to reduce treatment time and radiation. Function. How does it function? Using the human body to complete an electrical circuit. One side of the circuitry is connected to an endo instrument and the other end to the patient's body, patient's lip, or by an electrode held in the patient's hands. The impedance between the lip and the periodontal ligament is a known value. So as the file tip is advanced toward the periodontal ligament, the electronic apex locator detects the changing impedance values and indicates the approach to the apex on its screen. Classification. The first generation of apex locators, present by McDonald in 1992, they were working on the principle of resistance. It measures the opposition to the flow of direct current or resistance. When the tip of the reamer reaches the apex in the canal, the resistance value is 6.5. An example of the first generation apex locator is the Sono Explorer. Moving on, the second generation apex locator, they're based on the impedance of apex locators. They work on the principle of impedance. It measures the opposition to the flow of alternating current or impedance. It uses the electronic mechanism that the highest impedance is at the apical constructure. I repeat, it uses the electronic mechanism that the highest impedance is at the apical constructure, narrowest portion of the canal, that is. Impedance changes drastically when a canal is thought of being a narrow tube. Example is ENDODONTICS. Then we have other examples like the Apex Finder. It has got a visual LED, digital LED indicator. It is self-calibrating. Then we have the Endo Analyzer. It's combined with an apex locator and a pulp tester. Then we have the Digipex. Again, it has got a visual LED, digital indicator and an audible indicator. Like when you reach the apex, it gives a continuous beep. When you are either beyond or short, the beep is intermittent, going like an alarm. The disadvantage is that in large, if the large Teflon coated file, or if it's the narrow canal, or Teflon peeled off in curved canals. Now moving on to third generation apex locators, frequency dependent apex locator. Measures the impedance difference between two frequencies or ratio of two electrical impedances. Generated with composite sine wave current sources. As the file moves towards the apex, the difference becomes greater. Shows greatest value of the apical construction, allowing for the measurement of that location. The index is the original third generation apex locator. It was released by Yamashita et al. In 1990. It measures the difference in impedances of alternating currents at frequencies of 5 to 1 kilohertz. As the file moves towards the apex, the difference becomes greater. Shows greatest value at the apical construction, allowing for the measurement of that location. Advantage of this is the most and the best thing about this generation is it works in the presence of pus and electroconductive environment in the canal. All the other generations, we have to dry the canal, only then the apex locator can be used. The disadvantage, because this works in the presence of pulse and electroconductive environment, is that calibration has to be done every time. Every time you are going to use the apex locator, calibration has to be done, which means it can be a little time consuming. Now, then came the multiple frequency, or the fourth generation, now we call it, is the Apex Finder AFA, all fluid allowed. It works on multiple frequencies and comparative impedance principle, reported to be accurate regardless of origins of fluids in the canals. LCD panel indicates the distance of the instrument tip from the apical foramen in 0.1 mm increments. Audio time indicator, like we said before, and visual indicator and audio indicator also is there. Displayed as a bar graph canal condition indicator that reflects the canal wetness or dryness and allows the user to improve canal condition or working length determination. McDonald et al. Reported an in vitro study where he said that the Apex Finder, AFA, all fluid allowed, is 95% accuracy. Then came the dual frequency, which now has become the gold standard of apex locators and is now used to compare any new apex locator in the market. It is the Root ZX by J. Morita. It uses comparative impedance principle described by Kobayashi in 1991. Measures the impedance of 0.4 kilohertz to kH to 8 kH at the same time. A microprocessor calculates the ratio of the two impedances. The quotient is displayed on the LCD panel and represents the position of the instrument tip inside the canal. Advantages. Best thing, it does not require a calibration every time, thus reducing the time required to use it. Can be used in the canal as well as strong alkali or when the canal is empty and moist. Allows shaping and cleaning of the canal with simultaneous monitoring of the working length. Now we have apex locators with other functions. Now there is something called as the cordless electric endodontic handpiece with a built-in Root ZX apex locator. The handpiece uses nickel titanium rotary instruments that range 280 to 50 RPM. 3 automatic safety systems are there. Automatically starts rotation when the instrument enters the canal and stops when the instrument is removed. Auto start-stop mechanism automatically stops and reverses the rotation of the instrument when the torque threshold is exceeded. Auto torque reverse mechanism and automatically stops and reverses the rotation when the instrument tip reaches a distance from the apical cuts that has been preset by the clinician. So as you can see, as apex locators advance and as the technology is advancing in endodontics, now there are a single, before we used to require to buy 3 different instruments to do the RCT, to check the pulp vitality, to get your working length. Now in a single system, you are able to do all 3 jobs, thus reducing the time for per case. Now, there are other certain elements used in diagnostics like monitors are like this. It is again the same thing. It's got an apex locator and a pulp tester. Then you have a dent port ZX comprised of 2 modules that has got both Root ZX and Tri-Auto ZX. The advantage of this auto apical slowdown function for careful sculpture of the apical portion. Now, how does the general accuracy and frequency of apex locators, what does it depend on? Now, effect of pulpal vitality and the accuracy of electronic apex locator. Most studies have reported that pulpal vitality does not affect the electronic apex locator accuracy. In vivo study, Maeda et al. 1983 determined that the pulp status makes a difference in determination. He said that the status of pulp vitality does not affect the electronic apex locator accuracy. That is all for today. And thank you one and all. Have a nice day.